don't see. Okay, yeah. So I wanted to say, yeah, I wanted to present myself. I think I met most of you on Monday or yesterday, but yeah, I can comment that I'm from Barcelona Supercomputing Center. I work in the Earth System Services group, and I'm particularly interested on the connection between science and society, and particularly climate change science. I don't have too many slides, so I would like to welcome also people to interact and provide comments or maybe suggestions or share your own experience. I'm not sure I will see you if you raise your hand, all right? So
I'll
maybe
look for them. Yeah.
Okay, perfect. So I could only hear very few presentations during the week, but I believe that you learned a lot about climate change, climate distribution, but also the issues related to producing climate data, dealing with all the uncertainty and other troubles. So I would like to take it from there and speak about two aspects. One is what happens with once we produce climate data. And here an obvious answer is it goes to scientific publication. And it's a big deal, and I believe some of you are now working on your maybe first publications for your PhD. But yeah, it's sad to say that usually only a handful of people read this, apart from some really groundbreaking research. Usually it would be your close colleagues or peers who work on the same topic, perhaps some enthusiastic family members or friends at the beginning of career, but that fades away over time. If it's something, sometimes that might end up in IPCC, some of it might be aggregated in the summary for policymakers, but generally what ends up in scientific papers is not really affecting very directly decisions. So I will speak a bit about that, what we are doing to try to make new knowledge from this data together with different decision makers. So that will be one part of the talk. And another one is about these assumptions that we make. So I was on Sebastian's presentation on Monday when he mentioned very kind of ridiculous assumption that was made by looking into correlation between, I think it was the amount of chocolate consumed and the number of Nobel laureates. But we do make ridiculous, more or less ridiculous assumptions all the time, and a lot of assumptions we make about the system where we live, our socio-ecological system that we are part of. I joined the climate services field, the climate services community 6 years ago, and it was often assumed that I was first not a scientist, a social scientist. I'm often asked even nowadays if I'm a scientist myself. Then there were a lot of assumptions about what users want. So I was often be asked, what does user want? End user. So the whole this concept of user that somehow got entrenched in the climate services field is a bit problematic because it considers that there is someone who produces something and someone who uses. So it implies this unidirectional link. And end user makes things even worse. So you want to end the process. Well, we actually want just to open the process of this collaboration and creating together the knowledge. Then there was assumptions that there is something that someone wants from us, that this user is kind of an entity. So I was usually thinking of how do my colleagues imagine this user as someone sitting and waiting for us to give them data. So this is the assumption that we are now addressing, I think, much better in recent years, that there is a plethora of decision makers that we need really to dig into their needs and current practices. And so if we want to have better integration of conventional sciences in how decisions are made today related to the climate change. Another thing is that the social sciences, also one assumption was that what we do in the climate services teams is that we do questionnaires and then surveys, sometimes maybe interviews, but social sciences is something much more. So we do our own research and we try to understand really this complex system around us. So the idea of climate services, and Raul introduced it yesterday, and I believe Agla as well, is to put this multidimensional scientific and non-scientific dimension in climate knowledge. So it was very good concept, but in practice we do have, for example, I will often be taking climate services projects as an example. We do have all these different profiles, and maybe social scientists seem to have a central role because they are connected different scientific disciplines and other stakeholders, non-scientific knowledge of holders of non-scientific knowledge. But in practice, we often end up being in very different parts, for example, of one workflow, on different parts of the project. More often than not, the communication is not so integrated in the scientific project. As I said, it's getting really better, and I think we are different disciplines and are involved from the beginning of the project and really trying to create something that is much more shared and merged, that is really merging all these different disciplines. But it's not, still not ideal. And it's not an easy thing to reach this interdisciplinarity. We have we come from different disciplines, we use different methodologies, different metaphors, we have different viewpoints, even different views. So this is good, I think, good definition that says that we cannot just put all these different brains together. We need to make this integrated synthesis. And interdisciplinarity and then transdisciplinarity is actually trying to understand this complex system and the world around us, and to go beyond this small interest of individual disciplines. And when I said that we have different views, it's sometimes really literally. So screen like this might be familiar to some of you who maybe run climate models. And then this could be my working day. So I sit and speak with people. We do participatory research. We speak. We learn from fishermen, from farmers. So one assumption here could be that social scientists have much more fun. And for sure, it's not still, and it's a legitimate assumption, and I'm sure it's not late in your career to think about it. But what we don't want to do is we don't want to get in this trap of natural sciences versus social sciences. I'm back to this figure from my first slide. It came viral, I think, the last few days on social media, and it shows the ocean, world ocean. So instead of looking into continents as separated masses, we can look at ocean that connects the whole planet. And really, we need to make this shift and start looking in the planet and our sociological system as a unity. So we don't want this divide between climate service providers and users, individual versus society. We want to move beyond this dualism practically. And I want to recommend the book from Karen O'Brien, where she speaks about different aspects that matter if we want to make this societal transition. So it matters how we relate to each other, how we build the relationships, how we maintain them. It matters which metaphors we use and languages. It matters how we apply our agency as individuals or as scientists. And one quote from the book that I use here says, "To transform society, we need to shift from the us versus them perspective and acknowledge the entanglements and connectedness in our shared reality." So a lot of these efforts, our transdisciplinarity is trying to do this, to really try to merge better all the knowledge, all the practices, all the agency that we have available. And one good example that this is really advancing is this emerging of knowledge networks. So you might be familiar with sustainable city networks, with youth for climate networks. So all these networks that are really trying to share the knowledge and do the have a common cause and trying to do things together. It's a good example of trying to find this unity. And maybe just to introduce transdisciplinarity more schematically. So if we start from isolated disciplines, And then we add multidisciplinarity. So multidisciplinarity would be one institute, for example, that has all this. For example, universities usually have all these different faculties and departments, but maybe there is no cooperation whatsoever between them. And then pluridisciplinarity could be where there is some kind of cooperation, but not really coordinated one. And then in interdisciplinarity, we really try to have coordinated collaboration. We really try to work together on the same level without imposed hierarchies between disciplines. And then when we add other sources of knowledge to this, for example, indigenous knowledge of renewable energy practitioners, from farmers, then we reach actually transdisciplinarity. So we try to maximize all these different knowledge sources to produce something that can advise our decisions in the best possible way. To stay a bit more with transdisciplinarity, and I use this transdisciplinarity pyramid proposed by Max Neef in 2004. It gives a few levels that we should consider in transdisciplinarity. So the first level is empirical level, where we are trying to understand what's there, what's there in the world around us, and that's where we have climate science, we have social sciences that explore their aspects, humanities, politics, economics. Then there is pragmatic level, which is trying to understand what we are capable of doing. So what we are capable to do with our climate models, with communication that we are applying, with user engagement. And then there is a normative level, what we really want to achieve. So we want to achieve better adaptation to climate change, better decisions. We want to have knowledge that is co-produced between different actors. We want to have better planning in decisions. And then is the question what are the values that we consider when we are creating this knowledge, and which with ethics guides us. And these levels are that we need some kind of coordination with these levels, because this pyramid is then dynamic and iterative, and the process is not really laid consecutive. It doesn't assumes consecutive layers, but there is a lot of interchange between. Good. And let me see if I can move forward. Okay, I decided to stay in the pyramid. Here it is. Okay, so some of the very simple recommendations of what we can do to achieve this transdisciplinarity is first to start from our own teams, so to really have this earnest interdisciplinarity, to really respect and try to hear other disciplines and to work together. And that this implies overcoming this power and position that sometimes exist, and hierarchies that exist, for example, between different disciplines or between scientific and non-scientific knowledge. And as I said, we need to be careful about the metaphors and terminologies that we use. And this term user that is really very established in climate services field is probably not the best one. It's not that there is the ideal alternative, but probably we can say stakeholder or actor, or just the name who we are speaking about, as we need to acknowledge that there is all this hierarchy of stakeholders that we would like to interact with. And we need different communication channels and approaches to establish this collaboration with different stakeholders. And then we need this lasting stakeholder engagement, which can be done through knowledge co-production. And I will speak a bit now about knowledge co-production. I like this definition, so from Bremer and Meisch. So he said that it's a complex meeting place where several different academic traditions and practices, so we can call them disciplines, also converge, overlap, affect each other. Sorry, I will go again. So different academic traditions, which we often call these disciplines, and practices where we can integrate, for example, indigenous knowledge. When they converge, overlap, affect each other, come into conflict, which is very, very important to acknowledge, or cooperate. So coming into conflict and coming up with a common solution is also, I think, very healthy practice. And there is a plethora of definition and of frameworks of co-production. There is also a plethora of terms now that have this co-collaborative prefix. And I will very modestly use the one that we developed in our team, but there are also other interesting ones, and they usually have common elements. So we explained the co-production framework as having three circular elements. So we start with engagement, and I think that Agle spoke yesterday about awareness raising. So it's the first step where we try to speak about the problem, speak about what we would like to work on to find a solution. We would like to run, for example, our very high resolution models. So to try to get the audience, to engage them with the work that we are doing so that we can start working together. Very commonly we use social media, websites, blogs, mailing lists. Videos has become something very, if you can see my mouse, has become something also used more and more. So in the project Next Gems, which is developing the storm resolving climate models, so very high resolution global climate models, we use video, for example, as our key communication approach and engagement approach. So we provide video to summarize what the project is about, what are our goals, but also we use something that we called science explainers. So here the idea is that scientists themselves record the video or write it down, what they are planning to do in the project, but in an accessible language. So often it happened, at least in the past in the projects, that scientists would be working and sometimes the results come really at the end of the project. So for anyone who is not included, it's very difficult to understand what's going on in the project, what they can expect. And for us who are these kind of intermediaries and trying to engage the stakeholders, it's also very difficult sometimes to get these preliminary results or to make sure what the output of our work will be. So idea with the science explainers is really to follow the work of scientists and to give this kind of peek into the scientific world to non-scientific audience. So we ask our scientists to record video about their plans, and then throughout the project, they will be recording an updated video saying, okay, this went well, this didn't, this theory didn't work out, this plan needed to be changed because we didn't have capacity to run this model, or it turns out that we cannot resolve all the storms and all the clouds even with this high resolution. So that they really can allow the audience to understand how the scientific process looks like. And we thought that would be a much more honest approach, because it would also explain, scientific process is very difficult, but it's not easy for not scientists to understand this difficulty. They can only see the first promise, for example, in the project, and then the final output, which is something, for example, different, which often happens. So this one example of how we try to engage the audience. And then the next round, the next level would be involvement, where we really try to exchange knowledge. And there we use these typical social sciences techniques, such as interviews and surveys. But what we prefer, at least myself personally, are really these meetings and focus group discussion. I found that as one really powerful tool to speak with the audience, to try to find to conflict the different views and to try to find a solution altogether. And then the third realm, which we term co-development, where we really try to co-develop with between scientists and stakeholders that try to co-develop together new knowledge. We call it also empowerment. And again, this empowerment is bidirectional. So we think that stakeholders can be empowered by having better information and better knowledge for their decisions, but this collaboration can also empower scientists, because they can understand how their science fits into real world, what works, what doesn't work, and they can learn also a lot from the practices that these stakeholders apply. And here we can work together on, for example, case studies. In this project that I mentioned, NextGems, we apply hackathons. So more technical stakeholders, for example, for renewable energy, for fishery, for food security workers, they come and sit together with this project scientists, and then they look into what should be the output of these models that they can directly use, so that they don't need to deal with all the different variables and then calculate it, but they can, for example, they can directly have predicted energy power for wind turbines, and not only the wind speed and certain height, for example. And then there are other approaches that we can use to co-develop the, for example, trial climate services, to co-develop knowledge together. And I will, let me just see how, okay, we are fine with time. I will move to some examples unless there are some questions maybe now.
I don't see anything.
I'll go ahead with some examples of what does this decision making mean in practice. And I will give examples from Africa. I was for the Focus Africa project. I spent there last month, speaking a lot with the decision makers from Southern Africa, Southern and Eastern Africa. And one thing that I thought might be interesting example is to speak about how decisions are made based on seasonal climate forecast, and to speak about RCOF. And RCOF stands for Regional Climate Outlook Forum. RCOFs were suggested by WMO in, I think, 1997 as a platform where different climate scientists, national, regional, international, and also stakeholders sit together before the season. So it can be, depends on the region. Each region of the world, this WMO region, has their own arc of meetings. So there are, I think, 19 of them. So one would be, for example, for the Great Horn of Africa, or for Southern Africa. And so they sit together before the season. It depends on the region which season is the critical one. And then they discuss what will be the seasonal forecast. So this is a consensus-based decision making. So they don't only look at the output of one model, but then they also consider different models, both global and regional, and some statistical information. They look into the current circulation, and they also rely on participants' experts' experience, for example, from that region or from the past seasons. So we call this subjective decision making, or subjective forecasting in this case. It has, as I said, a long tradition now for almost, I think, 25 years. I assume it was introduced because of all the uncertainties that we have related to seasonal forecasting. Particularly in the past, there were much less sources of seasonal forecasts. So there is the WMO infrastructure for seasonal forecasting called Global Producing Centers. So there is, I think, 14 global producing centers that run their seasonal models. And then there is a lead center that provides multimodal. However, there was a lot of issues related with this type of making decision in more subjective way, because first, these forecasts are not verifiable. Secondly, for example, you cannot easily make an update of the forecast because you need to meet every time to discuss, to make the decision. So there was one paper published, I think, something like 10 years into the functioning of RCOFs, that tried to verify how good African RCOFs, this regional climate outlook fora, performed. And they found some evidence of systemic errors, and where the positive skill, for example, was not immediately didn't appear immediately in the decisions. And one of the common systemic error was over forecasting of the normal category. And this, we speak about the first 10 years of this century, more or less, where the, for example, trend in some of these regions was really drying, while this normal category appeared much more frequently in these decisions. as the results of ARCOS. And it's probably kind of safe bet, as forecasters don't want really to make two categories error. So if they say it will be a wet season and it ends up as a dry season, it could be perceived as bigger error than if they say it will be normal. It will be, the probability for normal category is the highest, but then we end up with a dry season. So it was already in 2009. So since then, there was massive developments of climate modeling. We get much better models with much higher resolution. There is also quite a few multi-model already available. There is this effort to produce Copernicus climate data store. I don't know if you were speaking about that in the past days. And this tendency to have open data. So with WMO data, the data belongs to member states, so to each country, and each country has a right to decide whether seasonal forecast will be open or not, open source or not. So there is another issue. And then with Copernicus, we have everything practically available. So there was a lot of reasoning for moving towards something that we call objective seasonal forecasting. And there were a few projects that already started preparing and capacitating national hydrometeorological services to start using more objective seasonal forecasting. ICPAC, which is Institute for Climate Excellence from Eastern Africa, if I'm not wrong. They also took over they were running these initiatives and trying to really establish this objective seasonal forecasting. And in 2020, WMO provided the guidance on operational practices for objective seasonal forecasting, where they lobby for the use of procedures that are traceable, reproducible, and well documented, and with a forecast that can be verified. And the use of dynamical climate models, the results we have from all these different climate models and multi-models as a primary basis for making decisions. And I borrowed the following slides from a colleague from Met Office who made the presentation for hydrometeorological services from Southern Africa that gathered together in Pretoria last week. So he gave some examples showing why objective forecasting can be better. And he gave this situation from 2019, October, November, December season, where for this southern region, there was the 55% probability that the season would be wetter. They have more precipitation than normal. And there was, which is very unusual percentage. So it was not common to have such a strong signal from the models. And there was certain circumstances that were they influenced these results, such as positive Indian Ocean dipole. However, not all the models, of course, show such a strong skill. Also have no skill, but haven't shown such a strong tendency toward the above normal category. And subjective forecasting here would probably lower down this probability, knowing that there was a trend toward drying in the past, knowing that more often than not it's drier than predicted. Maybe the subjective decision would be that there would be normal, for example. While with this, and it turned out really to be a very wet season. So which decisions we can inform if we are much more certain that the season will be wet. For example, in this region, there is a practice, if there is more water than commonly, that the farmers use more seeds so that they maximize the yield. In the areas that are, for example, flood prone, but they also that are large, they have hillsides and plains. They can seed, for example, on the plains, on the hillsides, avoiding the plains that can be flooded. So there are certain decisions that could have been made better following just the results from the models in this case. And there was another example from Eastern Africa, where which is apparently common situation for March, April, May, which is which has lower skill often, and then there was the prediction set 33 probability for each of the seasons. which is again a very difficult result to communicate, and probably with the subjective forecasting, there will be tendency to try to see how was the previous season and then to make some suggestion. While if we are just using results from model, we really need to confront this uncertainty and openly say, okay, there is equal chance that it will be very dry and that will be that we might have some floods or very strong rains, as that it might be the normal season. So my colleagues were arguing that this actually objective seasonal forecasting open more just confront us with uncertainty and with the need to discuss and to look in the other sources of knowledge. And some of them we spoke about yesterday. For example, look how vulnerable is the region, how was the previous season, how good is our food supply, what is the adaptation capacity, for example, of the communities. And then finally, with this relying on the models, we don't need only to give probabilities, for example, higher or lower precipitation, but we can also give some indicators more precise, for example, probability of receiving precipitation above a certain threshold. And then these thresholds could be developed together with users, for example, depending whether we look in Southern Africa and subtropical region, or we are more in the tropical region, and then also which crops we are looking into. We can provide certain threshold and then advise that there will be enough rain beyond or below this threshold. So it looks quite straightforward that we should argue for the objective, and that's the whole idea of all these models and all the efforts and money that goes in climate modeling. But in the discussion that we have afterwards with hydrometeorological services, it was not all that black and white. And here I would like to use points from a very good paper that was published last year by Findlater and et al. In Nature Climate Change. And it was looking into why climate services promise better decisions, but mainly focus on better data. And I think it resonates very well with this discussion that we had with hydrometeorological services. So in the paper, they found three areas where we are not doing so well, I think, with climate services, where we could improve. So first is focus that we should more focus on process and not only on product. And this is, I think, the issue with this moving to objective forecasting. So, for example, one participant asked, okay, if we move to objective forecasting, will this kind of eliminate, she said, does this process exclude the role of national hydrometeorological services? Of course, they have been developing this practice for last 20 or some years. And this is established practice. And when we say established practice, it's not something that just you're lazy to change your practice. This practice means that they believe in it. There is a trust between them, between those decision makers. So when you go from Markov, they go to National Hydrometeorological Services, those decision makers and decision makers further down the line. So those whom they are advising. So changing the practice really affects the whole this communication chain. Also, there are downstream products. So, for example, in Tanzania, they get results from Markov. They also get, so this subjective seasonal focus. They also have results from other models, and then they run their regional climate model. Then what they do is they look at the previous season to see how well it was, so they can conclude what might be the situation on the ground with the fields and with the crops. Then people who develop hydrometeorological bulletin, which is used to make recommendations for the coming season. The office that develops this bulletin, they speak with agriculture extension officers. This is a body that has this intermediary role between Ministry of Agriculture and Hydrometeorological Services and farmers. So these agents, they really advise farmers how to crop, how to harvest, when to harvest, how to deal with pests. So when our colleagues in Tanzania are providing this hydrometeorological bulletin, they also make forecasts in this subjective way because they consider all these different elements. They also look in the climate circulation, and they look observations from the past, for example, 10 days. to see if there was suddenly a monsoon, then they can adjust the recommendation that came, for example, from ARCO. So there is this process of making climate knowledge and making decisions. So it's not only the product that we can just change it overnight. So it does take time changing these processes. The second area where Findlater had also weaknesses was demand-driven versus demand-relevant. So they say many climate services would more accurately be described as relevant to assume demand, here we again to our assumptions, rather than driven by actual demand. So we assume that it's enough that we have a better skill or that we have a forecast that is verifiable. We assume that it's enough to give probability that there will be more rain than normal, while maybe people need consecutive to know how long the drought or the rain season lasts. So they need, for example, onset of the rain season or the number of consecutive dry or wet days. Or they simply need more explanation and more training about how to deal with these uncertainties and with probabilistic forecast. And the third area is now going beyond our maybe this topic of ARCOs, but it's about evaluation versus valuation. So Findlater et al., they found that in many cases in climate services programs and projects, we do evaluation of the quantified outcome. So this can be this improved skill. So we can validate our model and show that skill is becoming better. But then valuation itself ignores the whole process. And also with valuation, we usually have some predefined assumptions. So we want skill to be better by this percentage, or we want to have higher resolution of our models. But then we don't really learn what else was achieved through this process. Maybe there were new relationships built. Maybe scientists learned something from local decision makers, from local knowledge. So this avoiding of evaluation, which is much larger process and much more costly and needs to run throughout the project, it further blurs this distinction between better data and better really service or knowledge. And let me see. Yeah, we have 20 more minutes. So I wanted to give some example of some decision support techniques, which I can go ahead, or we can have a discussion. Let me check. There are no questions, so maybe I will go ahead. But yeah, feel free to interrupt. So I think in one of the breakout groups yesterday, we were speaking about how to, given all the things that we need to consider, how really to make a decision and prioritize our decisions or consider all different aspects. And there are certain techniques that help us do this. You probably heard about cost-benefit analysis is the most frequently used ones, but it's very focused on these monetary units. And I gave one quotation from the book, The Ministry of the Future, which I also warmly recommend, but I won't read it now. Maybe you can have it in the slides. But certainly cost-benefit analysis has its own disadvantages. Then I guess you spoke a bit about robust decision-making approaches yesterday. So in the robust decision-making, we try to explore how different options would perform under the different plausible futures. So for example, if we do storylines analysis with different plausible futures, we want to see how one measure would really perform, to see how good it is with all the uncertainties that we have ahead of us. And then there is the approach called multi-criteria analysis, and it's sometimes used for making climate change adaptation decisions. And I will give say a few more words about the multi-criteria analysis. So in the multi-criteria analysis, it's a common name for different techniques that can help us elicitate and aggregate the different decision preferences. So it really allows for this participatory decision making. And then we can involve stakeholders in the deciding which criteria we want to use. and also how each participant can say how important is each criteria for them. So this criteria could be something like efficiency, so how monetary efficiency of the measure. It could be this robustness, how well the measure will perform under different possible futures. It could look into how good this measure is, for example, the conflict resolution, for example, over the water use or anything else. And then in multi-criteria analysis, we aggregate these partial preferences from each participant to find one global preference. And then we can have something that is called group decision making to make this final ranking of preferred measures. And I have examples from a study that was done 7-8 years ago, now quite a long time ago, in the Alps. So we wanted to see how, what do stakeholders from the Alps think would be the best measures to adapt the water management. And we wanted to see what is the spatial distribution of these preferences. So the Alps is a huge, this mountain chain in southern Central Europe. It has the climate might affect differently different parts of the Alps. So some can experience drying, and others more wetter conditions. So we developed one decision support platform that uses multi-criteria analysis, and it was a spatial platform. So the participants could look in the Alps and select. We engage here experts, so there were people from these water management bodies or other people that are dealing with issues related to water management. And then participants could select one particular area in the Alps that they are familiar with or they are interested in, and then they can do this evaluation of measures. So we proposed 5 measures. Some would support more of hard infrastructure improvements, some would more improve policy measures for water, then some would work on awareness raising, for example, for improving water saving in households. And then we came up with a list of criteria that was previously selected in another participatory method with stakeholders. So, and then the participants would practically rank each measure against how good with this measure is for them performing against each of the criteria. And then they would give weight to criteria. So for some, this efficiency could be very important, how well will pay off. Or for some others could be this conflict resolution, for example, or how well it will perform, what are the side effects or environmental performance of this measure. And then we can look into individual results, so how each measure performs against each criteria. So here we see, and then we can look into overall results. For example, for the whole exercise, the measure that got the most votes was more like policy measure of improving planning instruments. But then when we look at the national level, how the measures perform, for example, for France and Switzerland, this improving policy was the preferable measure, while in Italy it was the awareness raising and trying to improve water saving in the households. Yeah, so this was just one example of how we can practically dismantle the way how we make decisions. So making decisions sometimes looks randomly and sometimes is done randomly, but then there are all these other different aspects, and with these techniques we can help decision makers really think through these different aspects and assessing them, and really considering how different measures could fulfill some of these criteria. And yesterday we were speaking about what happens when we have limited amount of money, which is most often the case, and when we need to prioritize, for example, between water users, or in the national level, we need to prioritize which sectors we want to adopt first. And this can help us, these techniques can help us really try to think more thoroughly through all the different aspects of this possible measure and its effects on different sectors and aspects and people. And my final example is just what happens when this decision making is not done in a participatory way. And I'm again back to Africa, and again one study that was done quite some years ago. So if we don't really do proper assessment and we don't understand what those who are supposed to apply this measure, what are the incentives and needs, it can result in this measure not really be well accepted or not being effective. So we were in Kenya looking into the problems, particularly in this region close to the Nzoia River, that are often flooded and but also have very dry seasons. And the common crop here was maize, but maize is very, very vulnerable and very susceptible to these changes in precipitation. And then my work was related to looking into who are all these decision makers who help us make better adaptation decisions. And there was a plethora of them, and some working more on from the government sector, also from NGOs, from research, some working more on a national level, but also quite a few local decision makers. However, in this particular case, the decision that was made was to provide early warning system. So for this was more for the weather forecast, to announce that there will be a flood or the coming season might be dry, through using radio broadcasting. However, there was no really any capacitation or awareness raising campaign before that. So in the conversation with local communities, we learned that they really don't have trust in these conventional forecasts. Every village has their own rainman, and there is this forum of elderly people from the region who meet together, and then they advise farmers what they should do, and they're trying to read the signs from the nature and to understand how it will be the next weeks or next season. So this radio broadcasting didn't really haven't been very effective for this reason, because there was no this preparatory stage before that. And then another thing was there was one, I think, very strong flood in the previous season, and a lot of maize crops were destroyed. So the government made supplies of sorghum seed, and sorghum is really drought and flood resistant. It's much more resistant plant. And there is now tendency, I saw now in, for example, in Tanzania, when I was last month, for example, there was shift not really to sorghum, but for example to cassava is now much more used than maize, and there is a whole new market for cassava, which is also much more, for example, resilient than maize. But when these sorghum seeds were supplied to the local communities, they didn't want to use them because they were not used to eating sorghum. So the staple food there is ugali, that's traditionally made of maize. You can make it also from sorghum or from cassava, but traditionally they knew how to make it from maize, and that's what they like to eat, or they were used to it. And another thing was that they were, for example, paying the school fees with maize. So sorghum really didn't fulfill their needs. So this was just to emphasize that we need to consider all these different needs and different practices when we are making decisions, and that's why decision making is such a complex thing. And yeah, we have I will close here with another quotation from this Karen O'Brien's book, so feel free to read it, and we have something like 10ish minutes either for a short discussion or for a small break before Marta speaks.
Just give us a chance to read that.
Sure. Okay.
And maybe people can think about questions. I certainly have a few, but maybe we'll wait. But quantum systems. Okay. So if people, we do have some time, I think 5 minutes maybe for some, well, I'd just like to, I'd encourage people to be bold. Come on, it's our final day. You can come up with a question. I think this concept of objectivity is really fascinating, because it's such a two-edged sword, isn't it? I mean, it sounds good. We all want to be objective, but any of us who are dealing with systems of assessment of performance or whatever, we just know that these tick box exercises don't really, they actually can be counterproductive. And I've been reading a lot of philosophy of science recently. I'll put the comment in a link in the chat, but there's one of the philosophers of science, Sandra Harding, from I think quite a famous paper from the 1990s, talked about what she called weak versus strong objectivity. And I guess to paraphrase it a little bit, weak objectivity is this kind of common standards and everything. And she makes the point, it builds in inequities, it builds in power structures. And she argues for strong objectivity, which is basically allowing people to challenge things. So I'll put in the thing. It sounds sort of, this is the heart of the issue, is that a lot of our thinking as scientists is, you could say, a little bit lazy, in the sense that we get into this thinking of what she would call weak objectivity, which was just based on what we're used to. And then it basically excludes people. And it's actually not, well, it's certainly not fair. And it's actually not even probably correct, because you're taking a very skewed view of things. So, but it's there's the term is used a lot, right? Objective, and even just I think Aglé must have showed at the beginning one of these now quite famous figure from the summary for policymakers of AR6 working one report with the hexagons, which is following an objective method of looking at where we can make statements about changes in extreme weather, and large parts of the global south are excluded. So that's a consequence of objectivity. So I don't know if you want to reflect on that a little bit, but it seems like it's a very kind of deep concept, and we have to, I think you used you didn't use unpack, I think it was some other word, unpick or something. Some of these concepts have to be challenged a little bit. Sorry, that was more of a speech, but I don't know if you have any
very
thoughts.
good. I mean, I'm also eager to read the paper that you recommended about strong and weak objectivity. I'm not familiar with it. Okay. Yeah, but there are many aspects. This is again one of the things of these metaphors that we use, and that can be quite tricky, and that can impose some relationships and some power dynamics.
Actually, you challenged the word user, and I guess people, we at least in the kind of WCRP and the sort of thing, the term that decision maker is used a lot, and I think someone's challenged that as well as being sort of technocratic or something. Wait, have you also found that that term is somewhat loaded, or is stakeholder?
The decision maker.
Yeah.
And I don't have an ideal term. Yeah, I'm challenging the term user, but without coming up with a solution. That's true. Stakeholders, I find it quite neutral. There is also this disciplinary, I think, tendency to using different terms. So we use in climate change adaptation community, they use a lot the term decision maker. Some other communities, they use the term actor. I know that people from Britain really dislike this term actor because they think it's only refers to movie stars, but we use it a lot in social sciences. I heard it quite a few times from some colleagues from the UK. Yeah. Yeah, but for example, for me, the term actor is good. Also agent, because we all have agency to react. As long as we really describe what we mean by the term, I guess, any would be good.
Yeah. Actually, Loritz has just put a question in. Loritz, why don't you ask it yourself rather than if you want to?
Yes, I can do that. Hello. So I recently learned that that East Africa is one of the places in the world where climate projections, they have the lowest quality. I'm not sure about the details, but I heard that they project that the climate should become wetter and wetter, but the opposite has happened. And I was wondering how that, if that is the case, how that plays into how these climate products, how objective and subjective you could say how that is made. I'm not sure if my question was really clear, but
no, it's a very good question, and I think with projections, maybe it's with the new models, I guess it's getting a bit better and more up to point.
okay.
But with the seasonal forecasting, there's also really high uncertainty, and the models are really not actually the models are really not very skilled for seasonal forecasting. Depends on the season and the precise part of the region. But that is a big issue for East Africa, and I guess that's one of the idea of these archives was really not to only blindly rely on climate models, but really to try to understand and to rely on our expertise and experience from the region. But yeah, that will be certainly one issue with this objective forecasting now for Eastern Africa.
Interesting. Thank you.
Thank you for a good question.
Okay, I think if we don't have any more questions, then we should take a break. I guess we're a little bit at 3 minutes, sort of like 2 or 3 minutes after. We can take 5 minutes and come back just a few minutes after the hour. Thanks.